Math 3, Unit 12B, Section 5. Today we're just going to be talking about linear, exponential, and quadratic models. We're not going to be doing a ton of solving. We just want to notice the difference between the different types of graphs and how you can basically state what they are. Okay, so linear means a line. Okay, your equation usually has a y and an x that are not squared, don't have exponents. Okay, this ends up making a line. Quadratic functions make your U-shaped graph, and they always have a squared term, an x squared term in them. Okay, exponential functions have a variable in the exponent. Okay, and they are all increasing. Okay, or all decreasing. Okay, so this is what an exponential function looks like, quadratic function, linear function. Okay, so here it says graph each set of points, which model is most appropriate for each set. So we're going to graph the points and decide, do we think it's linear, quadratic, or exponential? Okay, so I'm going to go ahead and I look at these points and I can basically, based on the points, just draw my coordinate plane kind of here in the middle. Sometimes we'll have really large numbers, so we might have to shift how we write the plane. So 0, 0, there's a point there at the point of origin, 1, 1. Then we have negative 1 and negative 0.5. And then we have 2 and up 1, 2, 3. Did I graph something wrong? Negative 1, okay. So what do you guys think? Yeah, I agree. I believe this is going to be more of an exponential function. Okay. I would like you guys to plot the next one on your own here for a minute and decide what you think it should be labeled as, and then decide in your groups if you guys all agree. Okay, so let's check it out. First point is at negative 2, 11, and I maybe should have shifted this a little differently, but I'm going to count by 2s. 2, 4, 6, 8, 10, and then 11. So I'm going by 2s. Remember, if you're doing 2s, you kind of want to label what you're doing a little bit so that the person knows. Negative 1, it's up 5, so I go negative 1 up 5. At 0, it's at 3. And then 1, it's at 5. And so to me, this looks, see how it's increasing and decreasing? The only type of graph that has increasing and decreasing in it is a quadratic. So with the graphs that we're looking at, exponential is either all increasing or all decreasing. Same with linear. It's either a positive slope increasing or a negative slope decreasing. Anytime you have where it's positive and negative, that's going to be your quadratic. Any questions? Okay, you're going to do the same thing here on these next two. Okay, did you guys already finish number 1? No. Okay. Okay, you should be doing number 1, the next problem. Shh. Jessica, did you do this one? Okay. Okay, so negative 3 up 6. Good. Negative 1, 0. 0, negative 1. 1, it's negative 1.5. What do you think about this one? Very good. Exponential is correct. Okay. Did you guys do number 2 as well? Okay, so negative 3 up 8. Negative 1 up 6.
Is this basically like what this whole section is?
0, 5. This, yes. Wow. It's going to change just a little bit, which I'll explain to you. 2 up 1, 2, 3. And then 3 up 2. Very good. Linear is correct. You can see this is making a straight line, which is linear. Okay, on these where it says you're going to write an equation, we are not going to do that today. So anytime it tells you to write an equation, you can skip it. Okay, now, one thing that we're going to end up doing is finding out the difference between numbers. Okay, and so if you're just looking at these are basically ordered pairs. Your x, your y, your x, your y, your x, your y, your x, your y, and so on. Okay, so right now you can see that each of our x's are going up by 1. We need to see what's happening with each of these y values. Okay, and so let's go ahead and separate them. And so how you figure out the difference between them is you're going to take 18,730 minus 18,254 and get that answer. You subtract them, and we get what? 470, oops, 6. Okay? So I took this 18,730 minus this one. Okay, now I'm going to take 19,215 minus 18,730. And I get 485. Okay, then I'm going to take my 19,695 minus 19,215, and I get 480. Okay, 20,175 minus 19,695, and that equals also 480. Now, this is real data, and so if you were to be putting points like on a graph, they each kind of keep going up a little bit. And it's not exact, but are they going up similar amounts? Yes. And so you would see something maybe kind of like this on a graph, but for the most part, this equation is linear. And so you're kind of making a best guess. You notice here that it's not going up and down, it's always increasing, okay? And so this we would label as a linear function. Do we have any questions there? Okay, moving on. Okay, so within functions, if you are always increasing, if you have a common difference, either increasing or decreasing, that's constant, that will be a linear function. Okay, a quadratic function is you start by getting one thing and you notice that there's really nothing in common, and then at the second set of differences, it's all the same. That is a quadratic function. Okay, an exponential function, you'll notice they multiply by the same number every time. Okay, and so based on these tables, we want to figure out, is it linear, quadratic, or exponential by finding the common differences, okay, or the common ratio. Sometimes you can look at them and you just know what's happening. Okay? When I look at this one, I notice that there isn't really a difference that they have. But do you see how they all kind of have a number in common? So do you know what they're doing each time between each of these? Very good. Each one of these is multiplying by 5. And so anytime you have a common ratio that you're multiplying by, that will always be what? An exponential function. So we can go ahead and label this one as exponential. Okay, so we go to this next one. What is happening? What would you do in order to get from? And sometimes it's easier to go backwards. Exactly. They are, well, yes, adding 3. From -2 to 1, it is adding 3. From 1 to 4, adding 3. 4 to 7, adding 3. Therefore, it is what? So anytime the first one that you do is the common difference, it's linear, okay? Because what's happening is like each time it's going, you know, up 1, right 3, up 1, right 3, or up 3, right 1. And so it is making a linear function. And you could always plot these if you wanted to, but that one is linear. Okay? What do you think is happening on the next one? They're multiplying by 5 again. Do you guys understand when you multiply 5 times 50, it reduces and gives you 1/10? When you multiply 5 times 1/10, you get 5 over 10, which reduces to a half. So each one of these is multiplying by 5. Therefore, it is very good. Okay, next one. Okay, so what does it take to get from 11 to 1? Subtract 10. Okay, from 1 to -5. Good, subtract 6. From -5 to -7. Good, subtract 2. From -5, or sorry, -7 to -5. Okay, so do you see how it's like, that doesn't look right, right? There isn't really anything uncommon. So you go to the next set of differences. Okay, and so what is happening between -4, or sorry, -10 and -6? Adding 4, good. From -6 to 2, plus 4. From -2 to +2, plus 4. So do you see now it's the same? So it just took 2 steps basically. When you have the 2 steps like that, it is a quadratic. Okay, try this next one on your own. And then if you notice at the top how it goes linear, quadratic, exponential. So on your fingers, tell me what it is. Linear would be 1, quadratic would be 2, exponential would be 3. Good, good. 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 Good, Matt. Good. So in order from at the top, 1 is linear, 2 is quadratic, 3 is exponential. Good, good. Good. Nope. Good. 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 Okay, so remember if you have a negative number and then it's a smaller negative number, you're adding, okay? And so we're basically trying to figure out how do you get from 6 to 13, okay? And so that is how many? That's 7. And so this is adding 7. To get from -13 to -6, you add 7. -13 plus 7 makes -6. Okay, how do you get from -6 to -1? You are going to add 5. From -1 to 2, and don't forget about, you have -1 to 0 to 1 to 2, that is adding 3. Good. And then from 1 to 3, it is, or sorry, From 2 to 3 it is plus 1. Okay? And then going to, since those don't have anything in common, we go to the next set of differences. And this is 7 to 5 is 2, 5 to 3 is 2, and then 3 to 1 is 2. And sorry, these are minus 2's. Okay? So they have a common difference at the second set of differences. And so that means it's a, very good. Okay, last one here. Did you guys already figure out what it is? Okay, so remember 1 is linear, 2 is quadratic, 3 is exponential. Good. Okay, so from 9 to 7, subtracting 2. 7 to 5, subtracting 2. 5 to 3, subtracting 2. 3 to 1, subtracting 2. Okay? Therefore, it is linear.
Our whole attention to be on this.
That would be nice. The average monthly balance of a savings account is shown in the table below. Which type of function best models the data? Write an equation to model the data. Guess what we are not doing? Writing the equation. So what do you guys, by looking at this one, what do you think this one is? I would say this one is probably going to be linear. The reason is, too, if you think about it, at 0, you're at 540. At 1, it's a little bit higher. At 2, it's a little higher. At 3, it's a little higher. At 4, it's a little higher. Now, when you're dealing in terms of real things, it's not always exact, okay? But this would be a linear function. If we notice that all of a sudden when it got to 5, it started going back down and getting less, then that would have ended up making it quadratic. Okay, are there any questions?